that resulted in, after we had done this whole transformation, later we found that especially the consistency in our operational stability, there was no consistency. Essentially, each team did it in their own ways, and some teams were doing amazing, others not so amazing because they were focused on other things. So that's why we took this framework that Google developed inside reliability engineering and is now being developed everywhere.
Hey there, and welcome to the StackPod. This is the podcast where we talk about all things related to observability because that's what we do and that's what we're passionate about, but also what it's like to work in a tech company. So if you are interested in that, you are definitely in the right place. Today's guest is a lead SRE at the biggest e-commerce platform in the Netherlands, which is bol.com. His name is Bart Enkelaar, and Bart is not only crazy about site reliability engineering, but also about music and how to combine SRE and music, which is quite the unusual combination. So let's dive into it and enjoy the podcast.
First and foremost, Bart, do you want to just introduce yourself and what you do and, if possible, where you work and that kind of stuff?
Yes, sounds great. Hi, my name is Bart Enkelaar. I'm a lead site reliability engineer at bol.com, which is the largest online retailing platform in the Netherlands and Belgium. I've been a backend engineer for about 13 years now, been at bol.com for 7 of them, so I'm quite happy there, and it keeps challenging me every day. And my latest challenge of the last 2 years is taking the next step on our DevOps journey, which is rolling out site reliability engineering to over 100 DevOps teams. So that's where my main focus is. And the reason that we felt the need for that next step on our DevOps journey is that we did our DevOps transformation in around 2016, and then 2 years later we were done, and we built pretty cool tooling that enabled our developers to do their own deployments and get alerts themselves, but we didn't spend enough time on what does it actually mean to actually combine development with operations, and that resulted in, after we had done this whole transformation, later we found that especially the consistency in our operational stability was just, there was no consistency. Essentially, each team did it in their own ways, and some teams were doing amazing, others not so amazing because they were focused on other things. So that's why we took this framework that Google developed inside reliability engineering and is now being developed everywhere, and why we're taking that as our next step.
How easy was it to put the theory into practice, right? Because Google's thing primarily it's a view of nirvana, and going back to the early days of Google, right? It was like a dream to go and work at Google, and I think a lot of people still have this utopian view of the Google campus, and they just do things differently and get more done. And for people who aren't aware, bol.com is an e-commerce site. So that people aren't aware of who bol.com is, but e-commerce site primarily based in the Netherlands. Is that correct?
The Netherlands and Belgium.
But how easy was it putting the theory into practice, if it was easy at all?
Yeah, it's not easy. It's definitely a journey and we've been because the first books came out in 2016, right? And back then, immediately, some of our operations engineers and some software developers at bol.com, they took notice, and they took these theories to heart. And those are particularly the ones that were already very operations aware and were applying it to their own team, to their own little corner of bol.com. And we found that more and more people got interested in these ideas, and that matched up with the problems that we were seeing. So what that means is that this has been a journey maybe already 5 years in the making, but we didn't really started taking it seriously until maybe end of 2019, which is when we did like a first pilot. We thought, well, maybe we can have a part-time team, and that was a wonderful failure where we learned a lot from. That was lots of awesome people together who did not achieve the things that they wanted to achieve, because bringing about that culture change, and essentially it is a culture change, that is really hard work. We're a 2,500 people company, like 700 developers, and getting them all to think alike on this particular topic is essentially a culture change. And so when that failed, we used that as momentum to start with a full-time team early 2020. So now we've been doing it for a year and a half, and it's a journey every day. We take steps, and we've identified a maturity model for our team. But as we were identifying that, we were also seeing that there's key pieces of enablement that we're still missing, key tools that we need to build or apply. So we've been doing this for a year and a half, and we're only now, I think, getting the traction that we really need. But there have been lots of learnings and things that made Bol.com a better place to engineer and to work and to buy along the way. But it's definitely not easy. But I guess that's what makes it fun.
Since you've instituted some of these changes and you've implemented the team, have you seen any practical or even like business objectives like improve, like SLOs and all this kind of fun stuff?
The interesting thing is that we were coming from a situation where we were measuring things quite traditionally. So like golden signals, but then pre-generated from a standard team to all the teams. And that was actually for only applications that run in our own data center. Our cloud applications didn't, by default, measure things. And then many teams, had to figure this out for themselves. For most of our applications, we're still in this area of, at least now we know how badly we're doing. And we know this in a more relevant way. But we have, of course, seen relevant improvements. Because one of the first things we did from SRE out was built a way to handle out-of-office support in a decentralized way that did not require all software engineers to be on call. Because both financially and gatekeeping-wise, we didn't want to ask all engineers to have to be on call, but we did want to have all engineers be responsible for their own software, for the running of the software. So we set up virtual teams of software engineers arranged per product domain, so per value chain, essentially. And they take the out of office hours responsibility for responding to alerts on cloud services. And where I'm going for benefits is that at one point there was this issue with a health check on PubSub. PubSub is our Google Cloud native messaging system, and we use Spring Boot, mostly Spring Boot based applications, and they come with default configured health checks. And one of them was failing with a new version of the PubSub driver. And in this application where we had the software engineers on duty arranged, that was discovered and fixed within 45 minutes. And then in 20 other applications that had the same issue, that was discovered 8 hours later. And it was resolved only the next day after they came to us to ask for a solution. So that was a clear point where I was like, oh yeah, this works.
Yeah, it's the critical event, right? The distinguishes between, let's keep things as is, or let's move forward. I think one of the biggest challenges you have in technology, especially at the most senior levels, is that there's always an appetite to keep things as is, because at least if I can keep the train going and it's still going at the same speed and it's achieving what it's meant to achieve, then that's it. It really usually takes like a critical event to kind of say, okay, well, this train is busted. We need to, either improve the tracks, we need to improve the train, it needs to go faster, it needs to go more reliably. It takes a long time to usually, especially with something as new as like DevOps, because it's sort of more of a buzzword. People always talk about DevOps, and especially when you're talking to C-level executives, they just drop the word container or Kubernetes. Okay, when are we moving everything to the cloud? Like, come on, where is the cloud? Let's get it in there.
Yeah, exactly. It's just other people's computers.
It's like actually we moved our solution, because obviously StackState, we're a 4.5-year-old company, right? So our software was originally built on-prem. It was an on-prem piece of software. We migrated it to the cloud, and like even our AWS solutions architect looked at it originally and goes, well, you may just want to look to see if you can take advantage of some services and go a little bit more serverless with this infrastructure, because it's going to be expensive otherwise.
Nice.
How do you actually do you ever have to deal with anything like cost or anything like that? I know a lot of people are always dealing with availability and objectives, but do you ever have to help developers manage the cost of their solution because they're using a stupid architecture, or they're looping in a way that just uses too much compute or something like that? Do you ever have to deal with those kind of situations?
Yeah, so especially also with our move to the cloud, cost became a very relevant issue, because basically the cloud is just more expensive. You get more, but
you don't have to pay for the rack up front, but you're going to pay for all the compute it's going to use at the end of the month. Exactly.
So that means now you have the capability to scale up, but you also have the possibility to scale up. And if that's unintentionally used by a bad algorithm, then you're wasting all that money. So with our cloud adoption, we actually had Peter Jan did this mostly. It was originally one guy, and I think then he got a team who really started focusing on this cost control angle. And this is also where our extra layer that we have around Kubernetes, around the cloud comes into play. We have an in-house developed tool that is a thin layer over Kubernetes, and it mostly accepts Kubernetes like YAML. I think they try to make it as transparent as possible. So what you read in the Kubernetes documentation, you can just put in those YAMLs as well. But in there, we can do overlays and safeguards for
the checks,
maintaining cost flow and also
approach, right?
Exactly. But to be honest, I wanted to continue on something you said earlier, where in innovation, there's always this balance between keeping the train running and getting better tracks and getting a better train, essentially. And I think that is the heart of what we're trying to achieve with SRE, because it's all about this balance between reliability and innovation. And I've been working on a talk that goes, that's basically all software engineering is doomed. Because the more value a system delivers, the more complexity is in that system, and the more effort you're gonna need to put in keeping that system operational. So if the total amount of effort you can spend remains the same, that means that the more you innovate, which should be adding more value and thus more complexity to the system, you will at some point reach a point where the total amount of effort it takes to keep the system operational is larger than the amount of effort you have to spend. So this like tragical law of software innovation, I think this is where the difficulty comes in that balance between innovation and reliability. And it's all about what do your customers need to have optimized. And it is never one or the other. It's always you need both reliability and innovation, and you need them in a controlled manner.
I think you're absolutely right, but I don't think that what you're explaining is necessarily a new problem. I think it's a problem that's
it's not
around since software began. Right, every time there's an innovation, there's something in the backlog that buckled under the pressure, couldn't scale, didn't do whatever, and sometimes these innovations may go in, but it's not until like you let's say you're an e-commerce site, right? So let's say I do an enhancement, it's June, then all of a sudden the Christmas holidays come around. So late November, all of a sudden there's an environmental change in that I've got, 500,000 more people logging into my website and buying PlayStations. Then all of a sudden, the whole thing goes down because of a bug that was introduced back in June, So, but I think.
Did you hear about this bug? So like, literally, this happened. PlayStation 5.
Dude, I went to I think this generation of consoles is the bot of like this is the dawn of the bot, because I was literally so I didn't get an Xbox Series X the first time, but I was then part of a Telegram group which would then send out a link as soon as one came out on one of the digital things. I managed to go to the Microsoft.com store. I added it to my shopping cart. It was in my shopping cart. I then go to click checkout, errors, always errors, constantly errors. And so it turns out that because there was so much traffic, I couldn't execute the checkout service. So I ended up just like pulling up a bit of JavaScript, running it in my Google Chrome console. It took 6 hours of looping the confirmation before I finally at 10 o'clock got a text message saying, "Oh, you've just paid $1,000 to Microsoft." But like that was a real thing, right? And that's an environmental change, but that's not necessarily a code change, but an environmental change affected the availability of that checkout service. But I think one of the big things that you are now going to see, and which goes back to your point, is that because we're now living in this Kubernetes containerized environment, the rate of change is not just code. Boom! There's so much now going into all of the nuance, right? So when you deploy your code base with that YAML profile, you're basically saying, okay, Kubernetes, you can only use so much resource with this particular function over here, and that can introduce bottlenecks that you didn't know about, But then being able to understand that, at that point in time, there was so much traffic that these containers were only able to execute 20 threads at a time, to get the execution of the checkout, is part of this new layer, if you will, of changes equaling, availability issues. I
guess the softwareification of the infrastructure layer, that becomes part of your design, and that becomes part of what innovates and what moves. And it's been quite clear to me for ever since I started working with Kubernetes, actually, that Kubernetes is not going to be the end step of our cloud infrastructure organization tooling. And as you do as a software engineer, I've been considering like it would be fun to write a new programming language one of these days, and but you want to write something that makes sense. And these two thoughts have recently combined in. Wouldn't it make sense to have a programming language that understands both the infrastructure layer and the business domain layer, so that you can actually basically like type check your infrastructure against the needs of your algorithms? I don't know.
I think something that can invoke elasticity across multiple services is definitely
yes,
something that is needed. I mean, at the minute, that is something that is generally missing, right? So if you've got Kubernetes, it will spin up as many containers as you tell it to in order to fulfill the workload that it's been provided. But as far as I'm concerned, Kubernetes is just the next step in virtualization, right? We went from a physical to VMware virtualized to now Kubernetes. But all Kubernetes is doing is running these containers, which are effectively limited operating systems to run specific purposes and fulfill specific things. You're still limited by the traditional virtualized world in that you can only give so much resource per container. The physical machine that they sit on can only do so much. I mean, and you can tell this because AWS and Google Cloud, they charge you based on how many minutes you keep the cluster active, not how many containers you're running and all this kind of fun stuff. It's like, okay, here's the cluster. It's using X amount of compute all the time, unless you give it more, and then that's it. So, but I think the next thing is where people are going to evolve to be serverless, and I think there's going to be a version of Kubernetes. It won't be Kubernetes; it'll be something else in the future, right? Which will effectively be able to not only manage maybe some traditional things like containers and maybe virtual machines and maybe traditional databases, because that's another thing that Kubernetes isn't really good at managing right now, right? Because you've still got a need for a database a lot of the time, even if it's NoSQL, MySQL, Graph, whatever, you're still going to need data stored somewhere. That's also going to get more complicated because I think more people with all these denial of service attacks and whatnot, that they're going to go to a more blockchain type thing. I think a lot of people don't understand what a blockchain is for the most part, but once they realize that they can distribute data, across multiple servers, areas, geographical locations, and you need so much access in order to put together that data, it's just going to be so much more secure, especially for customer data and GDPR and stuff like that. I think they're going to start making companies distribute data as part of GDPR policy, right? As opposed to just keeping your data for a specific amount of time. I know I've kind of gone off on a tangent there, but it's
no, but it's an interesting angle. So you use the like naturally distributed security, essentially, that a blockchain gives you as a defense mechanism against things like data hijacking.
Correct. Yeah. So people stealing data, doing a ransomware attack. Because at the minute, what's happening is that somebody opens an email, they lose their computer, or they may not even know that they've lost their computer. But all of a sudden, then all the services that they're connected to through VPNs, through all this other stuff, all the passwords that they're using, just get piled back in. Whoever that hacker is or that malicious entity, they're going in then and using whatever thing it is, and nobody is really distributing their data. Everything at the end of the day sits in either one area or one subset of areas, and that's how people lose their data, because it's not secure enough. Basically, that's it.
So how do you rhyme that with, because you're saying GDPR is gonna demand this, but like how do you rhyme that with right to be forgotten?
So it's the same thing, right? So with a blockchain, there's a ledger, right? And that ledger contains not just the transaction approvals and what's going on, but then also the actual physical data that's being transferred. You could easily do something where it's like, hey, if you've got a piece of data and it's not been verified in over 7 years, you could assume that that verified data is, or that data that was verified, because you could verify it by somebody logging into their account, somebody, accessing a piece of information, boom, as part of the ledger. Yes, they can do that. Yes, they can do that. Bring together the data. Let's present the data to that person. That adds a check into the ledger, right? You can say, okay, as long as you haven't accessed your data within 7 years, it's going to go. Like, that's it. Like, it's no longer part of our ledger. Does that make sense?
I think so, but because you'd have to encrypt it in some way, right? Because you can't guarantee that all parts of the distributed network will delete that data.
Yeah, you would have to do it as part of your in cryptocurrency form. They have this idea of the mint at the very beginning. So the mint defines the behavior and the availability of the cryptocurrency. That would be when you'd have to define these GDPR policies, so that there would have to be almost like a self-destruct on the data in a way.
Yes, exactly.
Do you know what I mean?
Interesting.
See, we went
idea.
Completely off topic there.
Yes. And it was fun. No.
There we go. We've just invented
what's your
the next
thoughts on
product idea.
Yeah. Well, if you build a database that is natively GDPR compliant, I think you have a killer feature for the future. I think that's something, and if that's also natively resilient against data hijacking, man, you can sell that, especially if it's also performant.
Well, I just need some smart people to build it. But yeah, no, it's interesting. So getting back onto some of the things that you're doing. I know you have a podcast. You've got some very interesting backstories. Yeah. I know your father-in-law wrote a book as well.
Exactly.
Let's get to know Bart a little bit more and his interesting backstory, as opposed to talking about just technology.
Okay. But I like technology. Talking about been doing some talks at conferences over the last year and a half, and that's been lots of fun. And in that, through that, there was a colleague that I respect a lot, and we always had really interesting differences of opinion while we were both working at Bart.com. It was like, yeah, but I think it's this. And it was like, yeah, but you think it's this. And we both really respected the way we disagreed with each other. Okay. So then when he left the company, I was like, hey, I'm going to miss our disagreements. And he was like, yeah, okay, so shall we just continue then? And that's why we started Friendly Tech Chats, which is on YouTube. And I just had... my wife and we just had our second child. So, yeah.
Oh, congratulations.
Thanks. He's 8 weeks old now, and he's awesome. So we had a little bit of a hiatus while we were getting to know our new family. But before that, every week we'd release like so this is me again, not my family. We'd release a new 10-minute episodes where we talk about software engineering stuff. And to be honest, mostly we've been talking about software engineering quality, because we both care a lot about building the right thing right. And that's quite hard. So mostly over the first half year, we've been discussing different ways to approaching test strategies test automation strategies, basically, as a software engineer. And then recently we've moved more into other aspects like SRE, and we just taped an episode on hexagonal architecture yesterday. So we talk about all kinds of stuff, and we try to find the disagreements, but to be honest, the more we talk, the less we disagree.
Yeah, that makes sense. Yeah. I think when you're working on something side by side, you've got the red lights going, and one of you is like, no, you're looking at the wrong thing, and you're like, no, I'm pretty sure it's coming from here, and you kind of put together all the alerts and the logs. Yeah, I used to do that. But mind you, some it's good that you guys got along. I found when I was in the ball pit trying to figure out root cause and dealing with a bunch of people that always wanted to know the answer first kind of thing, and were very, very opinionated around whether they were right or wrong. And then it was so satisfying when I'd like press enter on my solution, and then all of a sudden the application works. I would be like, "Hey, see, it's just."
Yeah.
It's not as satisfying after the fact because you don't get that ability to be right.
True. What I appreciate in being wrong is that afterwards you're better.
Yeah,
Yeah,
because you certainly don't forget when you're wrong.
Exactly.
That's actually when you learn. Yeah.
Yeah. I also sing in
do you now?
in an Irish folk band. Yeah. Because we were talking about let's get to know Bart. And I was saying, well, I have an amazing wife and two gorgeous sons. They're 2 years old and 8 weeks old. But I also sing in an Irish folk band, which is the Green Hill Travelers. And COVID is finally kind of loosening up, so we're getting ready to play again. So if anyone's looking for an Irish folk band, the Green Hill Travelers are great.
Yeah. Do you have a website?
Yeah. It's greenhilltravelers.nl. Okay. But there's also actually an album on Spotify, but that's actually not me singing. That's the previous singer. But he stopped showing up at some point, so then they got me.
It's a great plug. It's like you can listen to us on Spotify, but don't because it's the old guy. Yeah. We go. I don't know. If not, but don't listen to it. It's the other guy. Yeah.
It's at least those are the songs we play, and it's pretty decent. It's to be honest, these musicians are amazing. They're the best musicians I ever worked with, and I really love Irish folk music because that has so much heart. So it's great fun to do, and that's something I also do. And maybe bridging it back to technology, over the last years, I was saying I've been doing some talks, and in some of those talks, I'm also incorporating like music. I wrote a site reliability engineering musical for SlowConf, which is a 3-part musical, and the first scene is set to the theme song of The Big Bang Theory. It's if big nerd alert, but yeah, I've got all the geek creds. But it's basically a history of site reliability engineering set to the Big Bang Theory tune. And then the second episode is the second scene is a meeting, like an all hands meeting, where everyone is complaining about things that are going wrong, that they don't understand, and then the site reliability engineering is saying, oh yeah, you can fix this with an SLO. Oh, you can fix this with an SLO. Basically, all the problems you can fix with an SLO. And that is set to the theme song of Game of Thrones. It's like a slow man, build a slow man, build a slow. So that's and then it ends with there's no business like a slow business with a big. So yeah, that was. The site reliability engineering musical made for SlowConf, and it's also on YouTube. Maybe you can link it or something. It was a lot of fun to make.
I was going to attend SlowConf. I'm part of a Slack group for SREs, but some of those guys organized
the Seattle SRE thing.
Yeah, the Seattle SRE.
Yeah, exactly.
Yeah. Are you in there as well?
Yeah.
Yeah, so I'm in there. I'm in their Slack. I attended their coffee hours a few weeks back.
Nice. Yeah, I have an invitation somewhere, but it's next to all the other invitations. Can't do all the things.
Awesome. Well, thanks again, Bart, for joining us today. It's been a real pleasure.
And
I want to know
me.
more about this this musical. You gotta send me the screenplay or something, some content, whether it's recorded or something somewhere. That would be really fun to listen.
Thanks, and good luck with the StackPod. And if you have like a panel on SRE or rolling out SRE to people, or maybe music and engineering, I'd love to be in that.
Cool. Yeah, no, definitely. We will do. And yeah, thanks again for doing this, man. It's really appreciated. And yeah, hopefully we'll do this again soon, okay?
Thank you so much for listening. We hope you enjoyed it. If you'd like more information about StackState, you can visit stackstate.com. That's StackState.com. And you can also find a written transcript of this episode on our website. So if you prefer to read through what they've said, definitely head over there, and also make sure to subscribe if you'd like to receive a notification whenever we launch a new episode. So until next time.